Today's lesson is 9.5b, Simplifying Complex Fractions. You've already seen how to simplify fractions that have pieces up top and on the bottom. So for example, we've worked with factoring different fractions, and we've seen that you can cancel tops and bottoms, get something simple. You've also worked with putting together fractions that have unlike denominators. So you've seen how we need to get a common denominator by multiplying both fractions by a certain number so that you can get the LCD in here. And all of that has been really building up your ability to see fractions, to put them together, and part of it has been with the graphing of these fractions as well. There's one more type of fraction that we need to deal with, and that is a complex fraction. It means that it has a fraction within a fraction. So a fraction that has a fraction in its numerator or its denominator or both. So for example, something like this right here is a complex fraction where you have 1/2 divided by 3. It's a fraction that has a fraction in the top, in the numerator. So we're going to learn how to simplify those today. To help us warm up a little bit here, we're going to talk about how to combine fractions with unlike denominators, because one of the things you might see today is that you still have fractions that have unlike denominators that have to be combined. So for our first one here, we see that there's a denominator of y, and I'm going to rewrite this guy so that he is 1/1. So the denominator is 1 and y. We need to multiply this side by y. So we get our common denominators here. We combine on the top. So y minus 3 over y. And then remember, you're not allowed to cancel the y's when it's a plus or a minus here. It has to be multiplication in order to make it cancel. And then for our restriction here as well, we'd have to say y cannot be 0. All right, so that's a warm-up of putting things together. What do we mean by a complex fraction? So complex fraction, before we deal with this guy for a second, we're going to think about the fraction 3/4. So when we say 3/4, what are some different ways we could rewrite this? We mean things like this. We mean 3 divided by 4. So we mean things like 3 divided by 4. That's one way to say it, kind of a messy way. We could use the old-fashioned language of this division sign, 3 divided by 4. We could just say the English 3 divided by 4. Those are all equivalent ways of saying 3/4, okay? So I think what will be helpful for us is if you could think about connecting a fraction like this with this symbol or image here. That's the definition you want to focus in on. So when we think about 1/2 divided by 3, you can think of it like this. 1/2 divided by 3. And that connection is the same as these two here, 1/2 divided by 3. Once it's in this stage, we already learned how to deal with division. Last week we saw that division means that you change this to multiplication and you use the reciprocal of the second fraction, so it becomes 1/3. So we end up getting 1/6. That is the simplified form of 1/2 divided by 3. So that's our basic idea for today. Like I said, some of our fractions are going to need us to find least common denominators as well, so let's put the pieces together. First of all, the thing that you always want to do as your first step is to rewrite the complex fraction as the quotient of two fractions. That's this idea right here, or doing this. So rewrite it as the quotient of two fractions. We do want to check for restrictions, so that's still going to be something we watch out for. And then we're going to go ahead and do this reciprocal idea. There might be new restrictions, and this is important for us because we've now done a reciprocal. There's a flip, and then we simplify as best we can. So our examples for today, let's start with this. Simplify each complex fraction. So first of all, write it as a quotient. So we have 1 over x divided by y. Now, our first restriction we see here is that x cannot be 0, so I'm going to list him. And right now there's no restriction on y, it's just y. Division sign means I need to change to multiplication and reciprocal. So I get 1 over y as my reciprocal. And now that actually means here I'm going to have a second restriction. Y cannot equal 0 either. And then I put them together, 1 over xy. If there was anything that could cancel, this is where I would do it, but this is it. And these are my restrictions. All right. Second example, notice that your denominator here has a plus or a minus sign. We have to go ahead and combine those. We have to take care of that before we can even think about this quotient idea here. So we're going to deal with just the bottom for a second. So down here, we need to get a common denominator. So 1 over 1 minus 1 over 2y. So this guy needs a 2y and a 2y, top and bottom, and then this one already has the 2y. Again, I'm not even thinking about the top, he's just sitting there right now. So I have 2y times 1, which is 2y, minus 1 all over 2y. Now you might be like, well, Ms. Hanson, I still have this plus or minus sign here. Yes, you do. However, notice that now you have a single fraction down here. So this piece can be thought of as one piece. They're together. It's not one number plus or minus another number. It's an entire number value here. So once you set up with that, now we can finish the problem like we just did on the other one. So we can say this is 3 divided by the value 2y minus 1 over 2y. So this brings up our first restriction. Notice that the bottom cannot be 0. So if 2y was 0, it would be that y cannot be 0. So that's our first one. Then it's time for us to multiply by the reciprocal. So we'll say 2y over 2y minus 1. So second restriction over here, 2y minus 1. If that was 0, it'd be 2y equals 1. Divide both sides by 2. So y cannot equal 1/2. So these two guys. And now we need to simplify what we have here. Remember, this is multiplication, so you don't have to worry about a common denominator. So this is the same as 3 over 1. This is the same as 6y over 2y minus 1. Again, you can't cancel the y's here because there's a plus or a minus. And 6, 2, and 1 do not have anything in common, so nothing cancels. So this is your final answer, and these two things are your restrictions. All right, some more examples where we have to do these common denominators in here. The top one is okay. It's a single value, so we're going to leave it be. Bottom one, though, we need to think about this as being 2 over 1. This one needs to have an x and an x on the bottom here. So we're going to end up getting 2x plus 1 all over x. So this whole piece here becomes that. Once you get a single fraction over a single fraction, we can write it as 1x minus 2 divided by 2x plus 1 over x, which is 1x minus 2 reciprocal time x over 2x plus 1. Again, it's multiplication, so the pieces get multiplied. We end up getting 1 times x, which is x, and x minus 2 is in parentheses times 2x plus 1, also in parentheses. No x's on the bottom to cancel with this one, and obviously no parentheses up top. So this is it. Let's think about our restrictions. In our first step right here, we have x minus 2, so that means x cannot equal 2. That would cause it to be 0. And we have just x, so x cannot equal 0. Then once we flip it, we still have x cannot equal 2, but now we also have 2x plus 1. So that cannot equal 0. So 2x equals negative 1. X cannot equal negative 1/2. And then this one here has nothing new in the bottom. So our restrictions are cannot equal 2, cannot equal 0, cannot equal negative 1/2. And one more. So again, think of this as being 1 over 1. We need a common denominator of x. Top is already set to go. So we end up getting, let's see, this guy here is going to turn into x plus 1 over x. So 1 over x minus 3 divided by x plus 1 over x. And now the reciprocal. And now we can combine. So x minus 3, x plus 1, nothing cancels again. You do not have to multiply these out because remember we like to see what the vertical asymptotes or the holes might be. Alright, check for restrictions. First line here, x cannot equal 3 and x cannot equal 0. And then this one adds in that x cannot equal -1. Alright, you're all set.